China's high-resolution multi-mode imaging satellite has been officially put into use, according to the China National Space Administration on January 20. It is a civil optical remote sensing satellite with a resolution up to the 0.5-meter level. The satellite can provide high-precision remote sensing image data for industries including surveying and mapping, natural resources, emergency management, agriculture, ecological environment, residential construction and forestry. The earlier launched Beijing-3 is a small one-ton commercial satellite, a powerful AI satellite capable of taking high-resolution images of cities in a matter of seconds. It can take images clear enough to be able to identify a military vehicle on the street and tell what type of weapon it might be carrying. The Beijing-3's response time is 2 to 3 times faster than the United States Worldview 4, currently the most advanced Earth observation satellite. The Chinese satellite has a scanning band of 23 kilometers compared to the Worldview 4, which is 13 kilometers. It can take high-resolution photos over a world-largest city under 50 seconds.
The Beijing-3 satellite successfully launched this time is equipped with panchromatic multispectral two-way devices, which can obtain full-color multispectral satellite images with a 0.5-meter resolution. It has achieved ultra-high agility, ultra-high stability, and ultra-high precision observation capabilities. At the same time, it also adopts the technologies of intelligent task planning, intelligent image processing and intelligent mutual control. Innovative technologies enable the Beijing-3 satellite not only to have powerful image acquisition capabilities, but also to provide unique imaging modes. These innovative technologies enable the Beijing-3 satellite not only to have powerful image acquisition capabilities, but also to provide unique imaging modes.
For example, it can actively push scan imaging along any path such as rivers and highways. Such a transit of scanning can obtain high-definition images of the entire Yangtze River basin, and can also perform fast multi-angle imaging to obtain three-dimensional information of ground objects in all directions.
The Beijing-3 satellite will work together with the orbiting Beijing-2 remote sensing satellite constellation system. It will provide important support for major national needs such as the modernization of the national governance system and governance capacity, as well as the Beijing Winter Olympics, the construction of major projects such as the Shangin New Area, and the coordinated development of Beijing, Tianjin and Hebei cities as planned.
Beijing-3 satellite promotes the leap from 2D to 3D of China's commercial satellite for Earth observation, and is used to build a 3D live digital Earth to provide remote sensing big data support for China's urban refined management, disaster emergency management and other major national needs.
The world saw a total of 145 space launches in 2021, of which 55 were from China, 51 from the US, and 25 from Russia. China sent more than 300 satellites to space last year, although the US sent far more, of which most are small satellites by SpaceX. It is a major national science and technology project in China to build an internet with satellite that integrates the Space-Earth network. There are two major difficulties Chinese engineers face. One is to improve the accuracy of satellites. The other is to speed up the layout of launching satellites. Designer Li Li and her team are arranging the annual on-orbit imaging mission with Gaojing-1 satellite. This satellite is currently the world's highest resolution optical remote sensing satellite. The resolution reaches 0.5 meters. It is completely independently developed by China. In the past year, Gaojing-1 has completed imaging of 2,456 square kilometers around the world, providing strong support to monitor the effect of overcapacity reduction in the national steel industry and the third national agricultural census. Previously, only the United States, France and South Korea were able to manufacture such high-precision optical remote sensing satellites.
Only with sub-meter resolution, that is to say, only 0.5-meter resolution satellite remote sensing images are competitive in the international market. Such high-resolution images reveal the details that can distinguish the shape of the front glass and rear glass of the car.
Taking high-resolution images in space 530 kilometers above the ground requires breakthroughs in the high-precision technology of camera lenses. Engineer Zhang Jiyu is preparing a grinding and polishing agent. This is a key process to ensure the accuracy of the lens. The material of the lens and the grinding process are the national secrets strictly guarded by the aerospace powers. In 2016, Chinese engineers broke through in this area and made a great progress in development of high-resolution camera. The Wu Dengyun team is adjusting and testing the variable speed control torque gyro. It is another core technology to ensure the clarity of panning satellites for imaging. The controlled moment gyro enables quick maneuvering and stabilization of the satellite's attitude. China is the third country in the world to master the application of variable speed control torque gyro. It is impossible for a country to make its own satellites without its own ground test equipment. On the test target of the collimator test bench, there are 40 black and white fine lines with a diameter of 10 microns. If the satellite camera can clearly distinguish these thin lines, it then means that the remote sensing satellite can distinguish 0.5 meters of objects on the ground from 530 kilometers above in space. The black and white lines are clearly demarcated, and the test results are perfect. This test bench, independently developed by China, has provided experimental verification for more than a dozen high-resolution remote sensing satellites in China.
We must have the ability to autonomously acquire high-resolution images. Otherwise, if the remote sensing data are all in the hands of foreign countries, in this monopoly situation, they can cut supply. We then have no way to obtain such high-resolution images.
In 2022, the world's largest and super remote sensing satellite system, consisting of 16 optical satellites with 0.5 meter resolution, 4 high-end optical satellites, 4 microwave satellites, and several video hyperspectral microsatellites will be deployed. The construction is completed in Chinese hands. On December 14 last year, the Long March 3B carrier rocket successfully was launched and sent the Tianlian Type 2 into space at the Xichang Satellite Launch Center. Tianlian, as the name suggests, is the information chain in the sky, so it is also vividly called the satellite of the satellite. It mainly provides data relay and measurement and control services for spacecraft, space station and mid-low orbit satellites, and provides measurement and control support for spacecraft launch. During the live broadcast, the pictures are clear and smooth and the communication is always smooth. Behind such a miracle of interaction between heaven and earth is the construction of a powerful information exchange and transmission network integrating heaven and earth by relying on the Tianlian relay satellite system. Based on the high-precision positioning technology of BeiDou, the application of BeiDou navigation has become more and more extensive, not only in the field of mass consumption such as mobile phones and watches, but also in smart travel, smart ecology, and in agriculture, forestry, animal husbandry, fishing and other industries. From the positioning and navigation of mobile phone maps to takeout ordering and then to car parking, various applications of BeiDou navigation have been ubiquitous in our lives.
Now the BeiDou system is accelerating its integration with other new technologies. Especially the integration with strategic cutting-edge technologies such as the Internet of Everything, unmanned driving, artificial intelligence, 5G, and blockchain, which became an important enabling means for building new infrastructure.
As early as September 2009, China Starnet submitted a spectrum allocation plan to the International Telecommunication Union, short for ITU. There are 2 broadband spectrum constellation plans named GWA-59 and GW2. It plans to launch a total of 12,992 satellites. On March 7 last year, Bao Weiman, an academician of China Aerospace Science and Technology Corporation, had made it clear in an interview with reporters that we were planning and developing a space internet satellite and launched an experimental satellite. China has established a national net company, named China Xinhuang, short for GW, which is specially responsible for coordinating the planning and operation of space internet construction. In fact, no company in China has the strength to build such a huge constellation system with nearly 13,000 satellites. The establishment of China Xinhuang is a milestone in China's satellite communication and satellite application industry. The 3 major network operators have taken out many key staff to participate in the preparation of China Xinhuang Company. The GW constellation contains 2 sub-constellations. Orbit heights are also divided into 2 groups. The satellites of the GWA-59 sub-constellation are distributed in low orbits below 600 kilometers. The satellites of the GW2 sub-constellation are distributed in a low Earth orbit of 1,145 kilometers. The orbital inclinations of the two sets of satellites are distributed between 30 and 85 degrees. If we compare the satellite distribution and technical indicators of the GW constellation with SpaceX's Starlink, we can see that the GW constellation has many similarities with Starlink. For example, the number of satellites of the two is very staggering, and the orbital heights are divided into two groups. A group of very low orbits and a group of low Earth orbits, and the orbital inclinations are also distributed between 30 and 85 degrees. Both are satellite communication networks that can cover the world globally. According to forecasts, the low Earth orbit can only accommodate about 60,000 satellites in total. Since Starlink has currently planned 42,000 satellites, it will occupy a large number of extremely low orbits and low Earth orbits in the future. If we add the nearly 13,000 satellites planned by China this time, plus there are several other major constellation plans in the world, the Earth's low Earth orbit is almost full. China's declaration of the GW constellation plan at this time is actually competing for the Earth's low Earth orbit resources to prevent the country from facing a situation of no orbit available in the future. So this is very significant. The sooner the satellites are launched, the better. In terms of signal transmission frequency, China's GW constellation adopts the transmission frequency distribution in the two frequency bands of 37.5 to 42.57 GHz and 47.2 to 51.4 GHz. The signal frequency used by SpaceX Starlink is distributed in the relatively low frequency 12 GHz, 14 GHz, 18 GHz, around 28 to 30 GHz. Since the signal propagation loss is different in different frequency bands, it is very important to choose the appropriate signal transmission frequency. Usually in satellite signal transmission, the loss in the 0.3 to 10 GHz band and the 30 GHz band is relatively low. So we can see that the four frequencies used by Starlink are basically close to these two low loss bands. So it can be said that the good frequency band is preemptively occupied by Starlink. The frequency bands in satellite communication from low to high are C-band, Ku-band, Ka-band, V-band and so on. The C-band was used earlier and was mostly used for satellite communications in geostationary orbits. The height of the geostationary orbit is 35,786 kilometers, which is a relatively high satellite orbit. The signal frequency of the C-band is low and the gain is also low, but the anti-interference is strong, which is more suitable for services that have strict requirements on communication quality, such as TV broadcast data transmission. The C-band is currently saturated. The Ku-band resolution is slightly higher, the gain is higher, and the antenna size requirements are relatively small, which is convenient for the use of small ground receiving equipment. It is the golden frequency band of satellite communication. The currently available frequency band resources are also relatively exhausted. Compared with the Ku band, the Ka band has greater rain attenuation, but the frequency is higher, and the available frequency band bandwidth is also larger, which is suitable for high-speed satellite communication. Of course, the requirements for signal receiving devices are higher. Due to the depletion of C-band and Ku band resources, the Ka band has developed very rapidly in the past 10 years. And the Ka band is also widely used in the military. The frequencies occupied by SpaceX's Starlink are distributed in the two golden frequency bands, Ku and Ka. According to the radio regulations formulated by the ITU, the occupation of signal frequencies is on a first-come, first-served basis. So the good frequency band was robbed by Starlink, and China had no choice. In the past, China has suffered from the loss of frequency resources in the BeiDou navigation system. Fortunately, China has applied for 4 communication frequency bands of the GW constellation in 2020. Of the 4 communication bands, 2 are in the Ka band and 2 are in the higher V band. It should be a relatively efficient frequency band that is available at present. Compared with the Ku and Ka frequency bands occupied by SpaceX, it is still a bit of a disadvantage. However, the V band, because of its higher frequency, will help to achieve higher network bandwidth. In the case of good enough signal modulation equipment and coding technology, it is theoretically possible to provide better data bandwidth than low-frequency bands. Therefore, it also depends on the future development of China's satellite technology, which is not necessarily a bad thing, though. In addition to orbit and frequency, how to launch nearly 13,000 satellites in a timely manner within the specified time is also a problem. Some people will ask that the SpaceX Starlink can send 60 small satellites in a single launch. So how many small satellites can China send to space in a single launch? In 2015, China set a record of launching 20 satellites on a Long March 6 rocket. The Long March 11 is the best launch vehicle in China that is good at one launch with multiple satellites. The Long March 11 carrier rocket is capable of launching 28 or more small satellites at a time. If 2 satellites are released at a time, then 56 small satellites can be released simultaneously in one launch. In addition, the Jialong 3 solid carrier rocket being developed by China Aerospace Corporation also has a multi-satellite launch capability of more than 20 satellites per launch. And the launch cost is controlled at less than $10,000 per kilogram. The best bet is the Long March 8Y2. The new Long March 8Y2 rocket sets eyes on reusable launchers like SpaceX. It is a 2-stage medium-lift rocket, which will mainly be used for sending payloads to low Earth orbits and Sun synchronous orbits. A major advantage with Long March 8Y2 is that it has no side boosters, unlike its previous version, making it not only environment-friendly but also light to lift off. A future variant of the Long March 8 will be reusable, with its first stage and boosters retrieved through vertical landing.
In this air show, various types of communication satellites such as low-orbit wideband satellites were exhibited in the public exhibition area. Such low-orbit communication satellites can solve the problem of no network signal coverage in remote areas, seas, and high altitudes. At present, China's first low-orbit broadband communication technology verification satellite has completed in the area of sensors, network weather report, satellite internet plus 5G, plus Internet of Everything, maritime joint networking and other applications. Low-orbit communication satellites often require large-scale network operation, and the demand for large numbers of satellites. At the air show, the domestic model of the smart manufacturing production line for small satellites was exhibited for the first time, which displayed to the audience the satellite mass production scene.
This production line goes from the warehousing of parts to the test line, then final finished products. Now we have complete production line control. The annual output can reach 240 small satellites.
With the continuous improvement of satellite communication capabilities, the signal receiving equipment on the ground is also being upgraded at any time. At this air show, related companies also brought the latest satellite communication equipment that can be installed on aircraft, ships and cars. High-speed network communication services can be provided no matter in high altitude, sea, or desert.
This one is mounted on the drone, this one is mounted on the helicopter. This product is what we use on civil aviation aircraft, so we have internet access on the plane.
I am now in the base of Wuhan National Aerospace Industry. This park is officially put into use in May 2021, where China's first advanced small satellite production line is located, in which annual mass production can reach 240 small satellites. We have now entered the Spacecraft Smart Manufacturing Center. Behind me, these robotic arms are completing the satellite assembly. Of course, the birth of a satellite is inseparable from small parts. Then let's go to the satellite parts warehouse and take a look. The shelf seems to be as high as 5 stories. Here we can see that tens of thousands of satellite parts are displayed on these shelves. Let's ask the staff. Hi Mr. Wang, how accurately and fast can you find the parts you need?
We use an advanced warehouse management system to achieve intelligent control of our entire warehouse, such as the code of our material and parts, as well as the name and location are all in a smart control system. For example, a communication satellite we are producing now needs to have a standalone equipment, and then the stacker will automatically send our material and part boxes out of the warehouse. Operators place our standalone equipment on top of our set of pallets. There are more than 1,800 storage spaces in our entire warehouse, which can store over tens of thousands of parts needed by our 60 satellites on the line now.
The automated guided trolley has already brought the parts needed to the production line. On this operating table, this is the satellite's module panel. At this moment we can see that the robot will put these parts on this panel. During this process, we can see that the light below has been flashing. In fact, it is taking pictures and completing the positioning. We can see it moving to a position and taking pictures. There are 6 screw holes in the panel. See how precisely it aligns. It is still in the process of adjusting. Okay, it fell perfectly into the exact spot. It would take about 4 days to assemble such a panel by hand in the past. But with the help of a robot, now it only takes a day and a half to complete.
We have innovatively made a tight kiln coupling of this intelligent manufacturing technology and our satellite production. Improve the digitalization and intelligence of our entire production process. This in turn reduces the workload of our operators.
There's a final process to go through before the final product is certified. It is the vacuum thermal test system. This is to simulate an extreme vacuum environment. For example, the temperature of the side facing the sun under a high vacuum environment can be as high as 100 degrees Celsius, and the side facing away from the sun may be minus 100 degrees Celsius. Can small satellites operate stably and normally in this unpredictable and extreme environment? A satellite made here must pass this test. Next, it will finally usher in its new mission to be launched into space to roam freely.
With such an intelligent production line, the production efficiency of small satellites is increased by at least 40%, the production cycle of a single satellite is shortened by more than 80%, and the productivity is increased by more than 10 times. This production line realizes flexible customization to meet the production needs of different satellites. More production lines like this one will be built soon to meet the demand of 13,000 small satellites needed.
Our production line has an annual output of 120 small satellites. With a 2-shift per day, we can produce 240 small satellites a year. The satellite field of the future will be diverse. We cover communication, navigation, and remote sensing satellites, which are used for the power industry, financial industry, forestry, including navigation and aviation area.
Today, China's first batch of low-orbit broadband communication satellites has left the factory. In 11 months, Galaxy Aerospace completed this batch of satellites. The small-scale batch production capacity of the Galaxy Aerospace satellite production line was verified, exploring the low-cost development mode of our China's low-orbit broadband communication satellites. The batch of satellites has arrived in Xichang launch site and will be launched at the end of February or early March. After the successful launch, a satellite internet test network will be constructed. The delivery of this batch of satellites kicked off the low-cost batch development of Chinese satellites. Take a key step in the construction of China's satellite internet.
Today, from a reporter at the Aerospace Science and Technology Group, China's new generation launch vehicle, the Long March 8 Yao-2 launch vehicle, arrived at the Wenchang space launch site at noon today. Carry out all preparations before launch.
The Long March 8 Yao-2 carrier rocket was loaded into Tianjin port on January 13. After 7 days of sea transportation, it arrived in Wenchang launch site. The Long March 8 Yao-2 rocket is scheduled to launch at the Wenchang space launch site in Hainan from late February to early March. This launch will also be the first launch of China's new generation launch vehicle in 2022. The Long March 8 is a 2-stage medium-lift rocket, which will mainly be used for sending payloads to low Earth orbits and Sun-synchronous orbits. The rocket uses non-toxic propellants of liquid hydrogen and liquid oxygen, which generate water after combustion, ensuring that the launch process is environmentally friendly. The Long March 8 Y1 made its maiden flight on December 22, 2020 from Wenchang, sending 5 satellites into designated orbit. Compared with its predecessor, which had 2 side boosters, the Long March 8Y2 has no side boosters. A planned future variant of the Long March 8 will be reusable, with its first stage and boosters retrieved through vertical landing. It will have a capability of sending 56 small satellites on each launch. It's part of China's endeavors to develop reusable launch vehicles, which will significantly reduce the costs of space launches and thus have bright prospects in the commercial launch market.